Hi guys, welcome back. So in this video I want to explain a few Vex code that we're going to use throughout the workshop, and I have this RBD, the packed object, and creating a connect adjacent a constraint network between these guys. And let's increase this distance and let's set this to 0. So this is my constraint network, and I'm going to create a point VOP. And let's dive inside. I'm going to create a Voronoi noise, and I'm going to use the connect the position, and let's take a look at the seed. Now nothing is happening there. Let's increase the frequency. Nothing is visible, and the seed is actually a number that goes between 0 and higher. It starts at 0 and it's unique per Voronoi block. So I'm going to use that information to generate a random attribute. I'm going to say it's a color attribute. Okay, let's delete the primitives. I want to just see the points. Okay, so this is our points, and let's increase the frequency. And we need more points. So I'm going to create a grid and show this, I think, better with a grid. So let's scatter some points. And I'm gonna change the size back to 2. And let's create 100,000 points. Cool. And let's connect the same Voronoi. And let's set this to 1, 1 and 1. I'm gonna set this to 0, the jitter to 0. And we're getting this grid pattern now. We can play with this to get more Voronoi look. And and using the seed number, now we're generating a unique color per block. Now the thing is, each of these guys, they have a unique color, and then in some areas the color switches between these 2 points. Let me go back up. I'm going to use a triangulate node, and I want to mesh this point cloud. Okay, so now we have an actual mesh, flat wire shaded, and tint back faces. So this is my geometry, and if we look at the Voronoi, you can see we have let's lower the points, 4,000. You can see we have this island here, and then some primitives, they have one color and then a different color. So this primitive has one point that has a unique color, and the next one it has a different color. So what I want to do is I want to be able to isolate those guys. Okay, and I'm going to, let's do this here. So let's connect the same thing, and this is our Voronoi island. Let's increase the number of points. Let's put 60 and 60. Okay, so this is, we have many objects and we're creating a connectivity network, and this is the Voronoi. Some of these guys, they have unique value here, but then in certain parts the primitive has 2 different values, like this one here, it has purple and green. So we want to isolate those guys, and the way to do that is using, well, first let's export the seed number. So it's an integer, and let's call it seed. Okay, and let's go up. So we have the seed attribute. Let's take a look at that. See here. And what I want to do is I want to loop over each primitive and then query get the 2 points of the primitive. Let's say this guy. Okay, we want to get the first point and the second point, and then we want to get that number, the point number, which is not that but 2661. Once we isolate it, it changes. So we want to get that point and this point, and we want to query the seed attribute and compare that. Okay, so we're going to create a wrangle attribute, and it's a primitive attribute. And the way to access the point number of the primitive is using a prim point. So the first point I'm going to store in a pt0, and I'm going to use prim point expression, and the input is 0, and the primitive number is prim num. This is as it loops over, as the attribute wrangle loops over, this attribute changes each time with a primitive attribute. So that's prim num, and then I want to query the point attribute of the point number of point 0, of the first point that constructs that primitive. Okay, so then the next point, it's of index 1, and this is actually going to give me the 2 points I need, and then from there I'm going to do a lookup. So I'm going to call this lookup seed 1, and I'm going to look up the first point, which is coming from input 0, and I want to look up the attribute called seed, and I want to use the index, the point number pt1. So that's my seed 1, or let's call this seed 0, and then seed 1, and it's of point 1. Okay, so we're doing the lookup. Each primitive, we're getting what's the point, the first point of this primitive, and what's the second point. Once we get the ID, the point number, which is 2611 and 2669, we use that ID to do a lookup using the point expression. So now we have the seed that is available there and there, and then we're going to simply compare them. If seed 0 is different than seed 1, we want to delete the geometry using the remove prim expression, and prim num, and let's see, remove prim num, yeah, everything looks good here. Oh, sorry. Yeah, we want to remove. Yeah, we need a number. So we want to remove the first primitive. We're just gonna set 1 here. Sorry, the inputs are 3, and now as you can see, we removed everything where the point is different. Okay, using this code. And to do the inverse of that, we're gonna simply say if seed is equal to seed 1, we want to get the in-between clusters. In between, sorry, I didn't mean to use this node, but let me do one quick thing. I'm gonna generate a random color based on the seed. Random. So that's our random attribute. Okay, and then this is the in-between. These primitives, they have a different cluster or a different seed number on this primitive, and all these guys that we removed, they have the same value. Okay, so let's give these guys a red color, and this is green, and let's merge that. Okay, so now we have this island, and the idea is we're going to use something similar to create our constraints. Okay, let's go back here. I'm gonna do something quickly. Let me increase the frequency. So imagine we have a wall like this, and we have a lot of pieces, which is we have a lot of pieces here. These are the packed primitives. We want to tell the system that, hey, these guys are actually a glue constraint, and anything in between is actually a pin constraint. and this is going to allow the pieces to rotate and get that bending feature if we wanted to, but they're also going to have some kind of core that holds them together. They're not going to bend anywhere, and we can design these cracks into the geometry in any way we want. Okay, so in this case we're just using a simple pattern, a Voronoi pattern, but we can add a noise to it. So let me show you. We're gonna implement this properly in our system, but I just want to show the idea here. So now we're distorting that grid pattern. Okay, so it's not the same anymore, and this is we're gonna get cracks into the geometry here, where this is an entire block of RBD objects, and then it's allowed to rotate along this path, and if it rotates or it deforms, it has the chance of bending and staying in that position. Okay, I will I'm gonna explain this. It's gonna take a longer to do it twice, but I want to show this working in a video in a simple example so you guys fully understand the idea here. And let me go back to these guys. So what we've done now is we separated using this simple vex code, and the other thing I want to do with this code is actually to scale them down to the center. So we did this previously with a primitive attribute. So if we set this to 0, you can see now we're scaling them to 0 to the center, but we first have to separate them. Okay, so now if we scale, you see that we're scaling them to 0, which is what we want for the pin constraint. But we don't want to do this. We need this feature later inside the subsolver, and let me just show how what my idea is. So instead of querying the seed attribute, I want to query the point position. So that's going to be P, and it's going to be P here, and now I have point attribute. I have a new point attribute for these guys, and what I'm going to do is I'm going to use the set point attribute expression, and I'm going to change the first point. Let's call this position 0, position 1, and I'm going to change the position of point number 0 and point number 1 to be equal to the two position added together and divided by 2, and that's going to give us the center of this primitive. So set point attribute is the expression we're going to use. Set point attribute, and we want to set the attribute of the input number 0. The attribute name is P, and the point number is position, PT0, and the value is let's create a vector. Let's call this mid position, or let's call it center, and it's equal position 0 plus position 1, all divided by 2. That's gonna give us the center of the primitive, divided by 2, and that's center here. And then we're gonna do the same thing for point number 1. And now if we take a look, let's add a semicolon. If we take a look, we should see the center, the points all go to the center. Now let's take a look at why this is happening. The reason for that is because we declared these guys as an int, and they need to be a vector. They were fine for the seed attribute, but for the position we need to change them. And we need to also add a facet sop and make these primitives unique. And there we go. They're all now centered to the center. And let's do a blend shape to show this. So that's how we're scaling them down now. But because we've done it in Vex, we can actually do something useful with it inside the subsolver. And let's go back here and see if my system still works. It does. And what I want to do is I want that primitive centering that we did using this primitive guy. I actually don't want it to do it on all of these guys. I don't want it to change this, nor this, nor this. I only want to change it when the primitive has some deformation. And we're going to use the angle attribute that is available on the constraint. So the angle here, and let's create a wrangle node. It's a primitive wrangle. I'm going to paste that code, and I'm going to say all this I don't want to execute it unless the angle attribute is higher than 0.01. I want to use something really small because it's based on, it uses radian, not degrees. So if angle is higher than 0.01, I want to execute all of this. And let's paste that. Let's connect that instead. And this way it's not going to happen on all the points. And this is going to make the system even better. It's going to make it behave more realistically because we're not changing the anchor of all the points, only when the difference or when the constraint gets stretched too far, and that's based on the angle information. Okay, now one last thing, we got all this bending happening, and one last thing I want to do is I want to break this, and I'm gonna copy this and say if angle is higher than 0.05, and I'm going to delete all this, I don't need it. I want to change the constraint name. I don't want to delete the geometry. I want to change the constraint name to equal pin broken. And it's a primitive attribute, it's a primitive wrangle. Let's hit play. I guess we didn't hit that condition yet. So let's go back in and let's lower this even further. F.025. And by changing the name of the constraint, it means it's not going to work anymore. Okay, because we're only looking for the one called pin constraint. Yeah, and now it worked. So let's say 1. See how that works. See, the degree is very, it's very fragile, and so that broke. Let's set this to 2.5, and I'm gonna add an F here as well to make sure that it's picking up, just to make sure that everything is working as expected. And come on, break. Nope. Let's try 0.5. No idea. I guess it needs to be really low. 0.002. Okay, well, I think the angle is probably not working because it's not giving us exactly what we want. Sorry, I changed the wrong one. I selected this node. I'm gonna change this guy. Yep, it's working. So let's say 5, and I'm gonna keep these two guys the same. Okay, that didn't break it. 2. Okay. 2 here. I didn't, again, same thing. not this one either. Okay, I guess it has to be really low. But I think you guys got the idea. We're not going to use this. We're going to use something similar, but we're going to make the system, we're going to build a lot more rules in the system. Okay, let's do one more thing before we stop. So we made this guy. Let's copy this. Save this file as end. Constraint wall start. And I'm gonna change this to be a wider object. Something like that. Maybe a bit thinner. And let's do a VDB from Polygon. Let's gather some points. And that's a lot of points, so let's set it to 400. Okay, all looks good. We scale this down. Yep. And let's hit play and see what we get. I'm gonna hide this because the display it slows down the viewport. So it's gonna emit one box at frame 4. I'm gonna lower this to 20. And I'm gonna reset this to convex because it's not box doesn't work anymore. And let's hit play. Okay, let's increase the velocity of the box hitting the object 2 times or 2.5 times. And let's hit play. So as you can see, it's holding up pretty well. It's deforming. It's deformed now. It's not going back. But I'm gonna change the density so it's a lighter object, and that will make it less resistant, or at least it will bend faster. And let's increase the velocity even higher to 250. And let's make the box bigger. And maybe, yeah, let's leave it at that. Let's hit play. Okay, too much. So 120, and I'm gonna remove the deletion here, and let's set this to 0.01. And I don't want to delete the primitives. I want to see how it's gonna behave this way. So the main thing with this is that we have a lot of pin constraints, and that's really slow to evaluate. The other thing, the wall doesn't have any resistance. It doesn't have any core to it. There is no blocks or anything like that. It all looks the same, behaves the same. We don't want that. We want to see the clustering feature. Okay, we want to have a big block like this, and then a potential of something cracking along this line, and then another big block with a possibility of cracking along specific line, and that's what that's where the idea of the mixing constraint is going to come in. Okay, so it's working, and yeah, it's resisting. I think not all the objects on the ground are static, just these guys, because we're using the height position, the height of the pieces. I think this is static as well for some reason. Okay, so the other thing is I feel it's a bit slow, to be honest. And let's take a look at the constraint. Right now it's not that much constraints, but I'm gonna lower them, and or you know what, I'm gonna change them to points, and this is going to create a lot more constraints, and this is what a lot of workflow and people prefer to use, but personally I'm not gonna do this, and I will show you once we set up our system. You guys will have a better understanding of what I'm talking about. So I changed the number of constraints higher now. There's more constraints. There is a constraint where whenever there is a point, and that's going to give the wall a higher chance of pivoting, a better chance of articulating itself and getting deformed, but it doesn't mean it's what we need for destruction. It's resisting better for sure. And not sure why this object is static. Cool. So that's the idea of the bending metal, or at least the reinforced concrete. And I'm gonna set up the system using the my glue constraint or my constraint system to explain it to you guys, and then we're gonna move on to the actual real setup with the geometry. Thank you guys for watching, and see you in the next video. Bye bye.